Hello. So from today onwards, I'm starting a series where I'll be picking Kaggle Notebook and I'm trying to explain the notebook, not cell by cell, because in the notebook, many times the comments are there and what the particular code is doing that is mentioned. What I am trying to do in this particular series is going to give you the glimpse of hidden thought or how you should be thinking as a data scientist when you are going through this notebook that I'm going to explain you. So the very first notebook which I have picked for our series is the Titanic survival problem, which is a classic example any data scientist studies in the beginning of his career. So what if I told you just knowing someone's title like Mr., Mrs., or Master could predict whether they survived the Titanic sinking? It sounds crazy, right? But in this notebook, the author has proved it with the data. So when I am picking a notebook and telling you about the notebook, I am going to tell you the essence of the notebook, the wow factors in the notebook. Rest all, whichever is written in the notebook is there in the notebook. I'm going to attach the link of that notebook for your reference in the description so you can go download and play with the data. But certain things I'm going to tell you which are not there in the notebook, or which you should think when you're thinking of solving any data science problem. So the problem statement here which we are checking today is we are working with one of the most famous data sets in data science, and it is the Titanic datasets. It contains details about passengers, uh, the things like age, gender, ticket, class, fare, and the most importantly, whether they survived or not. You can see it here in this section. You can see this is the data set and these are the details. Now what do we do next? What is our goal? Our goal is to predict whether this particular passenger survived or not. But here is why this matters beyond just a data set. This particular problem is which problem? Classification problem. And this problem is something which every company uses all the time, like predicting customer churn, loan, defaults, or even medical diagnosis. So this particular classification problem you will come across in your actual industry and industry problems. So by solving this, what is happening? You are learning a skill used in real world data science and AI. Now how we are going to approach? Instead of jumping straight into code, let's first think like a data scientist because it is a very first problem in our series. What should be our strategy when we have a data science problem? It should be first to understand the data. So suppose you have this data, you have to understand the data. Then clean missing or messy values. So this data, no data is the clean data. In real world, no data is the clean data. So if you get a missing or messy values, what will you do? You should not just drop those values. Then you will be losing all the important information along with that. So it should be cleaned and missing values should be filled with different computation techniques. Now after that, once our data is clean, we should be creating features. Now this is where the actual magic happens. We will create features. After that, once we have correct features, we will train a model. Now this is an iterative process. You may have to go back again and again and create features or tweak your features or understand more about the data and create features and again retrain the model and evaluate how well it is performing. So in a nutshell, it is like a cooking. If you have cooked, you know the process. You have raw ingredients, then you do some prep, then you do actual cooking, and then you do testing, how it is testing. So that is our evaluation process. Now here I will just do the breakdown. Here in this notebook, first the data is cleansed. What is happening here is, this data set is also a messy data set. So it has missing ages, missing cabin info, and incomplete entries. So what the author has done, he has not deleted everything. He has intelligently uh, done a filling of missing values. You can see here in the missing value section. I will take you here in the sensible value imputation. Here the missing value computation part is done. You can go through the notebook in detail. Okay. Now what is happening here? We are estimating, or the author is estimating missing ages based on similar passengers. Because if a child is traveling with parent, he should be likely young. He will not be 60 or 50 years old. Now after that, what is the wow moment I said you? What is the magic moment? Is a feature engineering. This is where actually the whole thing gets very interesting. We don't use raw data. We create smarter features. So the very first thing that the author has done is he has created titles. So instead of just names, from those names, titles are extracted like Mr., Miss, Master, and guess what? What happens? I'll show you that part also. See here. You see this? So what happens? Title reveals social status, gender, age group, all in one. Now this single feature becomes insanely powerful. Now the second thing which is very intelligent, I feel, and the author has done, is creating the family size and the family variable. It is there. Here you can see this chart before that it is computed. Now this graph tells you something which you will which you'll feel is very important. You'll see this 2, 3, and 4. The people who are having the family size 2 and 3 and 4, they have their survival chances are more compared to the family size 1, 5, 6, 7, and so on. So it is very important variable, right? And what it tells us, that survival was not random. Families behaved differently. Small families means what? Higher survival. Alone or very large families means what? Lower survival. This is a classic example of turning raw data into meaningful insight. This is what you have to do in your real life also. When you'll get some data set, you have to extract the very important features which will tell you more about the data, the hidden traits of data. Now after that, we will go to the prediction part. Here the author has used the random forest model. Now what is random forest? You must be knowing. If not, then you have to go through that video. What is random forest model? Now think of it like asking multiple experts instead of one. Now each decision tree makes a prediction and the forest votes. Now why this model author has taken? Because it handles complex relationship and it works well with mixed data. Now it doesn't need heavy tuning for beginners. So that's why it is very good for beginners. Now which all evaluation metrics are used in this particular notebook? We will go to the evaluation part and check. Here you can see the building the model, and then author has also told about which variables he found important. Like you can see title, then sex, then fair, then age. All this are very important variable. P class, even family size, all that. Now in the prediction, as I told you, random forest model is used, and What is the metrics that is used? The accuracy is used. So what is accuracy? It is a simple. Out of 100 people, how many did we predict correctly? So if our model is getting 80% correct, 80 out of 100 correct, then our accuracy is 80%. So it is easy to understand, easy to compare. This is a beginner friendly, as we will go to the complex problems and notebooks. We will see different things in the evaluation side also, and we will that time also understand more about it. Now here is the big takeaway from this notebook which I want to tell you. Better feature matter more than fancy models. This, remember this always. You can use basic model also if your features are robust and they are best, then your model will work like a magic. But if you are having incorrect or not that important features, raw data only, then your model, even though it is very fancy, it won't work. Now you can use the most advanced algorithm, but if your data is itself weak, your results are going to be weak. Okay. Now insight one which I have to give you, titles like Mr. or Master, what they turned out to be the more powerful feature than only age. So it is insane thing because it is just a text, but still it gave you a very good insight. Insight two. Now social patterns like family size and class had huge impact on survival, and this our data told us. This shows data science is not just a math,